Hi, I'm Ramsundar Raman from the University of Michigan, and I'm here to present Censored Planet, an internet-wide longitudinal censorship observatory. Now, internet censorship is the phenomenon through which access to certain websites are blocked for users. There is anecdotal evidence that internet censorship occurs in many countries and networks around the world. However, the internet freedom community's understanding of the global state of internet censorship is limited. And this is because measuring internet censorship, especially at the global level, is a very challenging problem. Let me give you some reasons why. First, there are many different kinds of censorship methods, that is, ways through which censors can block access to information. The most common methods seen in the internet today are DNS manipulation, TCP/IP blocking, and application layer keyword blocking. Second, censorship and its targets changes widely from country to country, region to region, and even from network to network, creating the need for measurements of large scale. And finally, censorship changes over time, which creates the need for continuous measurements. Because global and continuous measurements have been challenging to achieve, most previous studies in censorship have focused on specific countries, especially Iran and China. Moreover, previous studies have only considered censorship at a single point in time, not accounting for longitudinal variance. The most common method previous studies have adopted to measure censorship is what we call direct measurement, where the researcher somehow gains access to a client in the country of interest to run reachability measurements. The client could be a volunteer running a particular software or an accessible machine like a VPN server. Now, although direct measurements have been very useful in the past, they struggle with a number of inherent challenges, especially when it comes to global measurement. For example, it takes tremendous effort and community involvement to get a large number of volunteers. Also, can you imagine how hard it would be for users in small towns with sketchy internet to continuously spend lots of bandwidth running tests to hundreds of keywords? There is also the issue of coordinating tests and making sure all the appropriate precautions are taken. What if measurements end up needing users to test pretty dangerous websites that put them at risk of retaliation? Now, a recent promising line of work has paved way for safer measurements that also achieve large scale. Using what are called remote measurements, these work try to infer if two devices on the internet can talk to each other without actually controlling either of these devices. For detecting each of the common methods of censorship implementation, a remote measurement technique has been proposed in recent years. We use these remote measurement techniques as the base for building Censored Planet. Augur measures TCP/IP blocking using IP/ID side channels, while Satellite or Iris measures DNS manipulation using measurements to OpenDNS resolvers. Quack and HyperQuack measure application layer censorship by sending measurements to TCP echo and HTTP servers respectively. Please refer to our paper for detailed information on how these techniques work. So far, remote measurements have also suffered from some challenges. The techniques are each specialized to detect one type of censorship and have only been used for a single snapshot in time. They're also labor intensive to run and suffer from problems with false positives. To overcome these challenges with remote measurements, we have developed the Censored Planet Observatory. Censored Planet uses these four remote measurement techniques to reliably and continuously collect censorship measurement data and includes methods to analyze the data to create a more complete and accurate view of global internet censorship than before. The Censored Planet Observatory performs both continuous longitudinal measurements and in-depth rapid focus measurements that analyze particular censorship events. The platform was launched in August 2018, and we have been continuously collecting censorship measurement data on 6 internet protocols in over 220 countries around the world. We test accessibility to 2,000 websites every week from more than 95,000 vantage points. In just under 20 months of measurements, we've collected more than 21.8 billion data points. And we've also expanded the scale of direct measurement platforms by over 42 to 360% in terms of the number of countries covered. We also have increased network coverage with a median of 8 and a maximum of 9,000 ASs per country. This map shows the vantage points used by Censored Planet in March 2020. As you can see, Censored Planet has vantage points in almost all countries and regions, with some countries having 10,000 or more vantage points. So, how is Censored Planet able to collect and analyze censorship measurements so reliably and continuously? To resolve challenges with previous remote measurement techniques, we adopt a modular design for Censored Planet, where each module contributes towards performing and analyzing large-scale internet measurements. The input scanner module selects a list of infrastructural vantage points from which we can run measurements and finds these vantage points using internet-wide scan data. The input scanner also selects domains and IP addresses for testing. As seen in this figure, the input scanner selects more than 20,000 vantage points each week for most techniques, and these vantage points are mostly stable over time. Once the inputs are selected, a scheduler starts off the remote internet measurements using Augur, Satellite, Quark, and HyperQuark. We continuously monitor system health to ensure measurement errors are avoided, and the raw data collected every week is published on our website. We next adopt methods to reduce false positives by confirming instances of censorship. We find block pages, such as the example shown here, using clustering techniques we have previously developed, and only consider measurements with an explicit blocking signal as evidence of censorship. Once we have confirmed instances of censorship, our next goal is to find a representative metric. We first considered just the fraction of websites blocked as a raw metric, but found that this metric was extremely volatile. While countries like China and Iran, with a national censorship policy, had low volatility in this raw metric, countries like Russia and Italy, with more heterogeneous policies, observed more variance. So to obtain a representative metric of censorship within a country that is not affected by outlier vantage points, we built an optimization model that obtains a smooth censorship metric for each autonomous system in the dataset. We observe that this smoothing process reduces volatility in the raw censorship metric while keeping censorship increases and decreases over time intact. Finally, we perform two types of time series analysis on the smooth censorship data. We first use a bitmap-based anomaly detection method to find anomalous censorship events over time. We also use the Mann-Kendall statistical test to identify trends in censorship. Now, I'd like to touch upon a few key findings from our 20 months of measurements. Using our anomaly detection method and manual confirmation, we were able to identify 15 key censorship events around the world. These events lasted for different time periods and were caused by different censorship methods, showing the need for diverse and continuous measurements. Social media and news domains were targeted in most events, while human rights domains were also highly blocked. 10 of these 15 events were not reported in previous work. We were able to find increasing levels of DNS censorship in more than 100 countries, the highest being in China and Turkmenistan. Unlike previous work, our findings show that censorship of encrypted traffic is increasing due to advances in deep packet inspection technology, which is a cause for concern. Our trend analysis also found 11 categories of domains being increasingly blocked. We compared our findings to an annual qualitative report on internet freedom released by the Freedom House organization, which is called Freedom on the Net. This report has been instrumental in the internet freedom field and has been used by many studies to select countries for measurements. Through our comparison, we found significant censorship in countries labeled as free by Freedom House. Moreover, the Freedom on the Net 2019 report covered only 65 countries, and we observed increasing censorship trends in countries not considered by Freedom House. Our findings show that quantitative results from Censored Planet can significantly complement qualitative reports like Freedom on the Net. Another unique strength of Censored Planet is the rapid focus ability to fire measurements on demand to investigate events. For instance, we conducted a rapid focus study using Augur measurements in Turkmenistan, where we got an indication that censorship was skyrocketing. We tested reachability to a bunch of Cloudflare IPs and IPs of DNS or HTTPS servers in April 2020, and found that more than half of the vantage points we have in Turkmenistan block all Cloudflare IPs, restricting access to thousands of services. To summarize, we find several interesting takeaways, including the fact that censorship varies over time and that censorship is common in countries previously thought of as free. This implies the need for global and continuous measurements that Censored Planet can provide. We also find that censorship of encrypted communication is increasing, which has implications for circumvention techniques. Please head over to our website, censoredplanet.org, where we're still collecting and publishing data. You can also see some of the visualizations of our findings and reports about other rapid focus measurements that we've conducted. We hope that Censored Planet data continues to be useful to the community in the years to come. With that, I'd like to conclude my presentation, and I'm ready to take any questions.